In this video, we're going to talk about the types of reactions, which is target 5.1. While we're doing this video or taking these notes, you might want to have your periodic table out because we're going to have to write formulas and balance equations as we do this. So there are 5 main types of chemical reactions. We are going to talk about 3 of the 5 types in this video. We will get to the other 2 later on in the unit. So we'll talk about 3 of the 5 today. We're going to start with a synthesis reaction. If you think about the word synthesis, you probably already know that means to make something. So in chemistry, a synthesis reaction means we're going to make one product. Quick review. Remember, reactants are what you start with, what goes into the reaction, and the products are what you make, what comes out of the reaction. So a very generic equation for a synthesis reaction, we take A, you add it to B, and you make AB. So you have 2 reactants, and technically could be even more. So we'll say 2 or more reactants. And you always make, here's the key, one product. So you have to come up with one final substance that you made, one product. So you put all the things in at the beginning, and you end up with one at the end. Here's an example. Iron plus oxygen makes iron 3 oxide. So iron would be like A, oxygen is B, and you put it together and you make AB, iron 3 oxide. Notice here, oxygen is O2. Don't forget about your diatomic elements. I'm going to take a second to write those down for you. Hopefully you have them already marked on your periodic table. Remember, you start at the number 7, that's nitrogen. You draw a 7, and then you add on hydrogen to get the 7th diatomic element. Just in case you don't have those, it's really important you know them, so let's write them down. So we have nitrogen, N2, oxygen, O2, fluorine, chlorine, bromine, iodine. So there's 6, and your 7th one is hydrogen. So if you don't have those already marked or highlighted on your periodic table, make sure you do that, because anytime we are writing a balanced equation with those elements, you have to make sure if they're by themselves, you make them diatomic. Otherwise, it's going to be incorrect. Now let's go back to this equation. We know it's synthesis because we took iron, we added it to oxygen, and we made one compound iron 3 oxide. But it's not balanced. So we have to make sure that it's balanced. So quick review of balancing. If it helps you, remember you can have your chart, your reactant side, your product side, and then all the different elements. So we have iron and we have oxygen. So right now I have on the reactants, there is no coefficient written. So remember, if it's not written, we know it's a 1. You can write the 1 down or leave it blank. So now, if I left it as a 1, I'd have 1 iron in the reactants, but 2 in the product. So that's not balanced. When we're balancing, remember you are not allowed to change the subscripts. The subscripts are these little numbers down here, so you can't change those, but you can always add coefficients. So I'm going to put a coefficient of 2 in front of the iron. And now I have 2 irons in the reactants and 2 in the products, so that's balanced. The oxygen, I have 2 right now, if I leave the coefficient as a 1, and 3, so that's not balanced. But if I put a 3 here, I can get 6 oxygens. So that would give me 6 oxygens in the reactants. And if I put a 2, that gives me 6 oxygens in the products. That's balanced. But look at when I added that 2, that now gave me 4 irons in the product side. So that becomes a 4. No longer am I balanced. So let's change this coefficient to a 4 on the reactant side in front of iron, and now it's balanced. And then the last thing we want to do is make sure our coefficients are in lowest terms, that we can't reduce them. So we have 4, 3, 2. There's nothing that they all divide into, so we're good. That's lowest term. So the coefficients would be 4, 3, 2. Don't forget to balance after you write the equation. So let's try one that's in words, and we have to form it into an equation and then balance. So sodium, that's an element. Remember, you want your periodic table, you'll find it on there. Symbol is Na. The word and is like a plus sign, so plus. Chlorine, well, that's one of those 7 diatomics. So Cl2. Yields, remember the yields is the arrow. The arrow always points to the products, and it yields sodium chloride. Now, really important, This is an ionic compound because sodium's a metal, chlorine's a nonmetal. We have to balance the charges. So if we look at the periodic table, sodium's in group 1, its charge is +1. Chlorine is a halogen, it's in group 17, so its charge is -1. +1, -1, they balance out. So our sodium chloride formula is NaCl. Okay, looking at it, sodium looks good, 1 and 1, but chlorine, we have 2 over here in the reactant, so let's put a 2 in front of the sodium chloride. But now we have 2 sodiums, so to balance it, we're going to put a 2 in front of the sodium. Optional, up to you. You can put a 1 here, or you can leave it blank. So this 1, if you don't write it, we know that you want it to be a 1. Okay, so those are synthesis reactions. You take 2 or more things, you put it together, and you make one product. Decomposition reactions. Something decomposes, it's breaking down or it's breaking apart. So decomposition reactions, these don't usually happen on their own. Things don't want to break apart. So to do a decomposition reaction, we usually have to add heat or electricity. These are forms of energy. So we have to have energy going into the reaction to make it happen. The general equation here would be AB yields A plus B. Notice that is the exact opposite of what we just wrote down for a synthesis reaction. So decomposition reactions, these are the opposite of synthesis. So it's the opposite of a synthesis reaction. RXN, that's just the abbreviation for reactants. So in this case, we will start with one reactant. Remember over here in the synthesis, we started with, we made one product. So we're going to do the opposite. We are going to start with one reactant, and then we are going to make 2 or more products. All right, let's try an example and let's look at a few things. So here's the first one, calcium hydroxide. Notice this triangle over the arrow. Hopefully you remember this just means heat is added. So if we're adding heat, we put a triangle over the arrow. If we added electricity, just a quick review, these should be already in your notes, but if you add electricity, remember you have your arrow and then it's kind of like a sideways lightning bolt. That's saying that you added electricity. So we start with one reactant, and it breaks down into 2 products, calcium oxide and water. Now let's make sure it's balanced. We have one calcium, so that's balanced, 1 and 1. And again, if you guys want to do the T-chart, if you want to set this up, reactants, products, depending on how comfortable you feel, that's up to you. Notice here, hydroxide is not on the product side, so we have to split up the oxygen and the hydrogen. So we have 1 calcium on the reactants, 1 in the products, that's good. 2, this 2 gets distributed through to the hydrogen and the oxygen. So we have 2 oxygens. Let's go to the product side. We have 1 oxygen here plus 1 here. So 1 plus 1 is 2. That's balanced for the oxygen. And then hydrogen, 2 hydrogens. Oh, when we distributed through, 2, 2. So this is already balanced. If you wanted to put the ones in, that's fine, but you don't have to. So this guy, this equation is already balanced. So always make sure, don't assume that it's balanced. Make sure, check it to see if it is. All right, so here's one in words, and we're going to translate it into an equation. So potassium chlorate. So potassium metal, its charge is +1. It's an alkali earth metal in group 1. Chlorate. Okay, so flip your periodic table over and look for chlorate. It's a polyatomic ion. That's ClO3 minus 1. So K plus ClO3 minus. Okay, that comes together to just make KClO3. Since we only need one chlorate, we don't need any parentheses around it. We only use parentheses around polyatomic ions if we need more than one. Then it tells you decomposes. So when you see this word, you know that means it is the yield arrow. You only have one reactant. So that's potassium chlorate decomposes under heat. Okay, so we're going to put a triangle up here because that's under heat to produce. So that means to make potassium chloride. So we already said K is positive. Now notice it's chloride, IDE. That means it's just chlorine as an ion. So Cl minus 1. Notice the chlorine is not diatomic when it's an ion. It's only diatomic when it's an element. So we have K plus Cl minus, so that just makes KCl. And, so that's our plus sign, oxygen gas. That's one of those 7 diatomics, so we're going to make that O2. All right, so to balance, K is balanced, 1 and 1. Chlorine is balanced, 1 chlorine on the reactants, 1 on the products, but the oxygen isn't. We have 3 on the reactants, 2 on the products. So what's a common multiple between 3 and 2? That's 6, so let's try to get 6 oxygens on both sides. So we're going to have to put a 2 in front of the potassium chlorate, because 2 times 3 is 6. When we do that, we would want to get 6 oxygens on the product, so let's put a 3 in front of the O2. And now let's check the potassium and the chlorine. So we have 2 potassiums, 2 chlorines. So if I put a 2 right here in front of potassium chloride, everything is balanced in its lowest terms. 2, 2, 3. All done. All right, and then we're going to look at one final type of reaction. This is our single replacement reaction. Single replacement, there's 2 different ways it could happen. You could have A plus BC yields AC plus B. Let me change the color marker. Might be easier to see if it's different. Or you could have A plus BC yields BA plus C. Now, when you do this, you can see that you have these A's are going to be elements, and then the BCs are going to be compounds. So we always have 2 reactants, and we always have 2 products, because look at the product side. And again, on the products, just like the reactants, you have BA or AC, those are compounds, and then B and C are single elements. So when you do this, when you have 2 things, you will always have 1 element and 1 compound on the reactant side, and on the product side too. You will have 1 element and 1 compound. Now, this compound, it's going to be on both sides, doesn't matter which one. This is going to be an ionic compound. So remember, for ionic compounds, it's a cation first and then an anion. So in other words, it's the positive and then the negative. So that's why you can have 2 different ways. So B would be positive because it's written first, C is negative. So if A is a metal, metals always become positive. So remember, metals form cations and nonmetals form anions. So if A is a metal, like it is in this case, it swaps spots with B, because metals are positive when they form an ion. So a metal will replace a cation. On this bottom one, the second example, it's a little different. This one, you can see it's swapping places with C because C comes by itself. So A in this case is a nonmetal, because B is written first, positive, C is negative, and it's switching places with C. So it's switching with C, so we know this is a nonmetal, because cations will replace cations in single replacement, and anions will replace anions. They're called replacement because they replace. So A replaces B, and we now have AC in this case. Here, A replaces C, so pushes out the C, and B is bonded with A. So make sure it's a metal replacing a metal, a nonmetal replacing a nonmetal. All right, so here we have aluminum plus iron 2 nitrate yields iron plus aluminum nitrate. So notice aluminum, you should know that's a metal. So this is a metal, and it's going to replace iron. So aluminum is a metal, and it replaces iron, which is the metal or the cation. In the second example over here, and we'll come back and balance that in a second, look at the second one. What's replacing? Well, not iron, fluorine is by itself on the reactants, Now, chlorine is by itself. So that means chlorine and fluorine flip spots. Well, this is a fluorine is a nonmetal, so it's going to find the nonmetal in this compound, which is aluminum, I'm sorry, which is chlorine. So fluorine replaces chlorine. So you have to check that first element that's by itself and see if it's a metal or a nonmetal. By the way, guys, these could be written the other way. So if you put, it could be written like this: FeNO3 2 plus Al. It doesn't matter if you put the compound first or the element first. So either way is okay. So don't expect the element to be the first thing written. All right, so let's go back and balance this. So we have aluminum 1, 1, that's good. Iron 1 and 1, that's good. Now I'm going to balance nitrate as one thing. So NO3, because I have it over here also, nitrate NO3. Well, I have 2 on the reactants, 3 on the products, so that is not going to balance. So what I need to do is, what's that least common multiple between the 2 and the 3? That's 6. So if I put a 3 here, 3 times 2 is 6 nitrates. And then a 2 here, 3 times 2 is 6 nitrates. Now I have 3 irons on the reactants. Let's put a coefficient of 3 in front of iron. On the products, that's balanced. And then 2 aluminums on the products. Let's put a coefficient of 2. So we have 2, 3, 3, 2. All right, let's try the last one. Um, Fe2, well, there's 2 there, but 3 here. So it's kind of like the last problem. We have to get 6 on each side. So I'll multiply by 3, 6 fluorines. 2 here, 6 fluorines. The chlorine, let's do that next. Chlorine, well, actually, we could do the copper, I guess, since we put a 2 here. So there's 2 coppers. So we'll need a 2 there. So there's 2 coppers. And now we have 6 chlorines, 3 there. And again, notice the chlorine, this is diatomic. So we have to make sure we have that 2 there. So don't forget these diatomic. Same thing here, diatomic fluorine. So this guy is also diatomic. Okay, so we have covered 3 of the 5 types of reactions: synthesis and decomposition, which are opposites of each other. Synthesis takes 2 things and makes 1. Decomposition is the opposite. It takes one thing, it starts with 1, and it decomposes into 2 or more. And then single replacement. In single replacement, we always start with an element in a compound and we produce an element in a compound. We will hit combustion and decomposition in the future.